Yeah, I can hear you though.
Okay, hello and welcome to this March session of the Open Security Summit. Thank you for joining us. We are joined by Fraser Scott today, who has got a great session for us. So I shall pass over to you, Fraser. Thank you.
Thank you very much. All right, I'll try and keep one eye on the chat for questions as we go, but I'll probably try and answer them at the end, but feel free to chat or ask questions as I go. So I'll do a quick introduction about who I am. I'll spend a bit of time giving some background and context to what we mean with our architectural risk analysis and the open threat model format. I'll then go into the proposed open threat model format itself and describe how it works and what's in it. And then hopefully have time at the end to finish off on a very quick demo of what you could do with it potentially, and hopefully some time for some questions as well. So just a quick introduction to me then. I'm Fraser Scott. I'm the VP of Product at Erius Risk, which is a threat modeling company, product company. Previously involved in threat modeling within the financial services industry for a few years, three years or so. Before that, cloud security, DevOps, sysadmin, all that kind of stuff. And I've been involved in the open source threat modeling space for about 7 years. There's an open source threat modeling project called ThreatSpec that is mine and somewhat neglected at the moment, but we're not here to talk about that quite. So the title of the talk includes the phrase architectural risk analysis. So I'd like to spend a bit of time starting there and really sort of looking at what we mean when we talk about architecture and risk analysis in that sense. So on the screen here, you can see a number of definitions of what architecture could be. There are other definitions. The first one's probably the most intuitive, common sense definition of architecture, the overall system and how things are sort of plugged together, etc. I think the second one's a little bit more interesting though, because it's talking about the relationship between typical architecture in terms of the application and architecture in terms of the sort of the infrastructure, and it's not always clear where that boundary lies. So there's no single definition of what we mean when we talk about architecture in the context of IT systems. But my favorite one is the third definition, which is architecture in the broadest sense, are basically the decisions that you wish you could get right early on in a project. So they're the harder to change, the big impact decisions that you're making, like do we go with this technology stack or this technology stack? And undoing those decisions is particularly hard. But the caveat here is that you're probably not going to get those as correct as any other decision you make in the early stages of a process. So it's those kind of decisions that are important to make, but also you have to recognize that you're probably going to be making the wrong decisions at some point in the process. So that's, architecture in a high level. So what do we mean with architectural risk analysis? Well, probably more commonly referred to as threat modeling, or more broadly, secure design or security by design. And it's probably worth just spending a minute talking about what why security by design in particular. There's a lot of security stuff out there. There's SAST and DAS and pen testing and SIEMs and SOCs and all that kind of stuff. And all of that is necessary, but they all tend to focus on the particulars, particular vulnerability in this particular version of a package, is this particular line of code, or this, network connection from port A to B on, protocol C, or this incident somewhere in the system, and what they did and what attack path they took, etc., etc. So it's very much focused on the details, and that's, as I said, necessary, but what it misses is the opportunity to step back and look at the big picture, look at the context, look at the relationships between things, and that's where threat modeling really comes into its own. Threat modeling's a good way to look at the whole picture and understand what the security of a system means in that holistic sense. Worthy of note that OWASP late last year included insecure design as one of their top 10 categories. And again, you can have a well-designed system with implementation bugs, vulnerabilities, etc., that you could go and fix. And that's why we still need SAST and DAST and all this other kind of stuff. So even with a perfect design, you could still have implementation flaws. But conversely, even a perfect implementation, 0 bugs, etc., of a insecure design is going to have a bad day. So you can't just, just run your SAST and pat yourself on the back and feel confident that you've done everything you need to do from a security perspective if your system is fundamentally insecure by design. So threat modeling is a critical process from that point of view, because it's looking at providing the context that a lot of other security processes miss out on. And for those, I would imagine, this is the Open Security Summit, I would imagine most people here are probably fairly familiar with what threat modeling is, but for anyone who's not, I'll just give you the 30-second tour. Probably the best, and we talked about this the other day actually, one of the best ways of framing threat modeling is this 4-question framework from Adam Shostak. And this is not a methodology, it is a nice framework that describes how you could do threat modeling in different ways. So each of these can be done in slightly different ways, but broadly speaking, you've got this thing that you want to threat model. So what are you building, or what are you working on, or what is the scope of this thing you're trying to threat model? The next question is, well, what can go wrong? What are the threats? And there are many different ways that you can come up with potential things that can go wrong to the system or application. And that's all good fun. That's like whiteboard hacking. You can sit in the armchair and you can come up with all sorts of cool threats. But that's, as fun as that is, the point is to make systems more secure. So the third question then is, well, what are we going to do about it? Now we've come up with all these cool threats, we need to actually make a change. We need to do something differently in order to mitigate or prevent or at least detect some of these threats. And then, like any good process, this should be somewhat self-reflective. So question 4 is, did we do a good job of answering the previous 3 questions? Are we threat modeling the right thing? Are we threat modeling it at the right scope or at the right level? Are we finding the right types of threats, or are we constantly biased to one type of threat? Are we actually implementing what we say we're going to implement, or is everything just accumulating on a backlog somewhere? So this 4th question helps make sure that the threat modeling continues to evolve and improve. Now, at this point, shifting security left is probably bordering on cliche, and but that's a good thing, to be honest. So we all know the value of shifting security left, but we also know some of the challenges associated with that. So I'm just going to sort of talk briefly about why this is important from a design point of view. In production and sort of when our system's live and you're maintaining it, going back to what we were talking about with architecture, it's very hard to make architectural changes for something that's running and live. You can't just rip everything out and replace everything typically. So that's a very, very difficult process, a very costly process to have to do from a security perspective. A lot of security is very much focused at the moment on putting security in the CI/CD pipelines, automating it, but perhaps even sort of from a Git point of view. That's awesome. So we're seeing a lot of automation there that's absolutely necessary. But if you've already written the code and if you've already sort of designed and built the building blocks for that application, maybe it's not been deployed yet, but it's still, you've gone through all of that development effort, that's still quite late to be finding some of these issues. So this is the classic space of we've gone through this process, but we've now found a bunch of vulnerabilities in the system. We can't push it to production because of these issues. So it's a lot better than trying to do everything in production, but it still comes with a relatively high cost. So from a threat modeling point of view, the ideal is to start on the left. So if you've got a design that's nothing more than a whiteboard diagram, it costs you nothing to change your architecture at that point. You're just changing a line on a whiteboard from A to B. So it's very, very cost effective in that sense. You can redesign to your heart's content. You're also proactively identifying requirements at this stage as well. So we need to make sure that this thing from here to here is secure, and we can build that in as a requirement, like a non-functional requirement as we're designing it. The downside here is that typically this process is manual. It often involves, a lot of threat modeling involves getting people into a workshop, bunch of developers, bunch of architects, bunch of security people, and whiteboarding and designing these threat models over a period of hours, possibly even days. So it's not particularly scalable, and it's pretty expensive from a process point of view, not so much from an implementation and fixing point of view. But design time security also comes with its own sets of challenges. So the architecture diagrams, if you're going into a threat modeling session, you probably went through your Confluence pages to rip out all of the diagrams that you may need for that session. Typically, those architecture diagrams are out of date the day after they were created, because the minute someone went and changed something in the actual implementation, the architecture probably wasn't updated. And so you get this implementation drift that's very common with architectural design, which was better suited to waterfall at the time. But there's also some other interesting sort of emerging problems. So, what do we even mean with architecture when we are dealing with things like serverless or microservices or no code, basically where the architecture is emerging from the code rather than deciding in advance where you're going to plug your cables. This thing plugs into this box and this thing plugs into this firewall, etc. That's a lot more dynamic. It's a lot more something you don't know in advance. The architecture may not be designed in advance in the same way that it used to be. And of course, with increasing sort of complexity in the environment, more and more tech stacks, higher and higher levels of abstraction, the whole thing is just becoming quite a mess. So there's some interesting architectural challenges that impact security. And when we think about software development, we still think about it as a bit like a manufacturing process. So this, slightly facetious car manufacturing picture is showing, the conveyor belt of Jira stories and developers working on them, and then you've got some sort of sprint planning over here somewhere in the future, and it's just this conveyor belt of work. And we tend to use language like work in progress and batches and pipelines, all very much that manufacturing type language. And I know a lot of lean takes inspiration from manufacturing, and that makes sense when you're dealing with physical products. The question is, does it make as much sense when you're dealing with building applications and software? So there was an article in the C++ journal in 1992. Bear in mind that this is 9 years before the Agile Manifesto was put together, and this talks about from Jack Reeves, talks about when we actually think about manufacturing from software. When you're writing code, you're not manufacturing software. You're not on a production line creating software as a product. You are in a process of design. Writing code, the actual design itself, testing, debugging, all of that stuff is a process of design. The actual manufacturing is near instantaneous because it happens in the CPU. So everything that we typically do with software development is actually much more like a design process than it is a manufacturing process. Which is why Agile came about in the first place, which is why you'll see more and more, I think, shift towards other approaches that are trying to get away from this assumption that we're dealing with a conveyor belt of features. And this commit strip as well puts it nicely. If you think about what code is just a very precise specification that describes some business behavior that you want to see happen when it's executing in the CPU. So even a binary file is essentially a design specification, not a product in the same sense as a physical car would be. What we're looking at here is a Wardley map. Wouldn't be Open Security Summit if it didn't involve a Wardley map. And what this is showing is some sort of fictitious music streaming service of some sort. On the right, we have highly commoditized needs and values, part of that value chain. And on the left, we have the genesis sort of things that are still being developed and designed and innovated on. The reason why this matters is if you were building some software, you're not going to go and create, you're not going to spend an entire sprint creating something that reads a YAML file. That would be, unless you had some very weird needs, that would be a complete waste of time. There are plenty of libraries out there that can read YAML files. There's no reason why you would go and implement that yourself. So a lot of this stuff that we need to do is already commoditized. It's already available, or at least productized as something that you can just pull off the shelf and leverage in your situation. And what typically happens is, if it's a well understood problem, it becomes productized or even commoditized. We don't have to go and build servers anymore. We just go and rent one from Amazon in the form of cloud computing. So things evolve to the right, which means most of your engineering effort is on the left-hand side. And that means you're dealing fundamentally with uncertainty. having to do something that's unique to your context. You're trying to solve a problem for your customers in your environment with your technology in your situation. So again, we're back to the situation of, this is not like civil engineering where we know the properties of metal, we know the way that the water flows in a river and things like that. That means we can build a bridge over a 2-3 year period in a certain way. What we're left with is a lot of discovery, a lot of uncertainty, a lot of experimentation and design. So when you're thinking about building an application, what you're fundamentally left with is a continuous, iterative, and most importantly, revisionist process of design. So your software, as I said before, are design artifacts. Your binaries are design artifacts, and you're constantly iterating and rewriting and improving these designs, not a process of deciding how much steel you need to buy in order to build a bridge. And this is an inherent property of software development. Because of the nature of software, it's not the same thing as something physical. I would highly recommend watching any of the videos by Kevlin Henney. That is not a typo. That it's not Kevin, it's Kevlin Henney. He talks a lot about this stuff. Very interesting. Also talks interestingly about how software doesn't have a natural scale, in the sense that a building has scale relative to us. Now, if software development is continuous, iterative, and revisionist design, that means we need continuous, iterative, and revisionist threat modeling. So threat modeling is a design time process. Software development is fundamentally about a design time process. Therefore, threat modeling needs to be aligned to that as well. There's no point threat modeling once a year if your software developers are changing things on a weekly basis and pushing stuff into production every week. Your threat modeling has to be in line with the design process. Now, this is where the good news is. Luckily, things like cloud and to some extent as well, probably Docker and Kubernetes and things, has provided us with a bit of a silver lining here. With things like infrastructure as code, the code is the design, but it's also then what's deployed. It's describing the architecture from an infrastructure point of view as code in that design stage, in the same way that you would expect from any other part of the code. And from a security perspective, then this is kind of the first time we can pass architecture automatically and not have to worry about drawing diagrams that are becoming out of date. We can inspect the design in real time, if you like, in that continuous, revisionist, and iterative way. So why an open threat model format? It's the other half of the title of this talk. As we said, architecture is often defined in many different formats. If you're lucky, CloudFormation and Terraform, etc., but also potentially things like Visio or other architectural systems. So within any organization, you probably have different sources of what design means within your organization from an application perspective. It could be a combination of, we've got CloudFormation, we've got some Visio diagrams, and we've got the application code itself. So threat modeling as a practice then really needs to evolve, and an open standard can help accelerate that evolution. And I'll talk about that in a second. We've also got a bit of a challenge with threat modeling where we don't really have a common language. So, you know, where one organization may be talking about components and threats, another organization may be talking about elements or something like that. So having a standard helps to at least create a common language that we can sort of focus on. And the OWASP has a pretty good diagram for some of this stuff as well that we actually leveraged in the open threat model standard. And this helps organizations communicate where they want to communicate, which we'll talk about in a bit as well. So again, another Wardley map, this time showing a very, very basic view of threat modeling in the context of a system. The blue circles and lines show the sort of the now situation. You've got a system. Off the back of that system, you can have a diagram, which is very much custom built. You know, somebody had to go in there and create that diagram. And you maybe have a threat model off the back of that diagram, and you've got a library of threats and controls that's a little bit more productized or commoditized. And that gives you your whole threat model. What we're trying to do with the OTM, this open threat model standard, is really shift the threat model to the right so that it's something that's much more reusable, something that's much more shareable, something that's much easier to leverage in a number of different contexts. And that allows us to innovate and do new things on top of the notion of a threat model. So we've got here something like threat model ops or TM ops. You're seeing this in machine learning, models and things like that were very much in that custom space. They're becoming commoditized. So there's now ML ops about how you manage and control and deploy and all that kind of stuff, your machine learning models, because these things are becoming more standardized. And you can then build on top of the OTM specification and do more powerful things like automated architectural analysis. So see OTM as an enabling sort of force multiplier for these kind of innovations. As a couple of use cases, there seems to be like 3 major use cases here. If you've got some sort of threat modeling process and you want, by creating a common representation, you can have different sources of different designs all ending up in the same sort of common representation. So that enables you to easily support different types of architecture, different types of design representations within an organization, and then bring them into this common format. This also means that you can exchange that common format and that data with other parts of the cybersecurity ecosystem. So if you need to provide some context to your SaaS tool, passing a threat model in an open standard would allow you to easily do that, and do that in a reusable way. And I think one of my favorite example use cases is an exchange between organizations. So if a software vendor wanted to publish a threat model for their application or for their software, being able to do that in a standard format means that's immediately reusable, and it's not just a document that someone can go and read and has to do something with. That makes it a lot more tangible and powerful in terms of what organizations can do to bring that threat model into their context and into their organization. And just to give you a bit of an example, this is what it would look like at a high level. You've got various design artifacts. You've got various parsers that can take those design artifacts and generate a single type of representation in that open threat model standard, which can be leveraged in the ecosystem, can feed into an architectural risk analysis engine, and can, you know, then fit into the rest of the SDLC or CI/CD pipelines or whatever. So I'm now going to switch and probably slow down a little bit, switch to the specification itself. It's, as you'll see later, it's published on GitHub. The specification is a description of a YAML file format. The specification itself is released under Creative Commons. Very much looking for people's feedback and for their contributions and suggestions and pull requests and all that kind of stuff. So we'll talk about that in a minute. So think of this as a proposal, not it's set in stone. So if there's things you don't agree with, would love to hear from you. But at a high level, it's YAML or JSON, same thing more or less. It's been very much inspired by the Open API, so that it should look fairly familiar looking through the specification, and it includes all of the kind of things you'd expect to see from a threat model representation. You've got metadata about the project or the thing that's being threat modeled, the idea of representation, so you can have different types or different views, I think, as Brooke Schoenfield was referring to on Monday. So you can look at one application from different perspectives, as a diagram, from code, from Jira stories, and you can capture these different representations within a single OTM file. We have assets, things you care about, components, the building blocks of a threat model, trust zones, data flows, threats, and mitigations. A couple of other cool things about the specification: a lot of the objects within the specification can also have attributes, which are, you know, arbitrary key value pairs or nested key value pairs or arrays or whatever you want to do with it. So if there's metadata that you want to provide about a threat, for example, that isn't supported by the specification, you can always at least put it in the attributes, and then your tools can pass those details out of those attributes and do whatever you want with them. The specification does provide some basic risk related properties. There's a CIA triad and trust zone ratings and things like that. Had an interesting discussion the other week about maybe replacing this or making it a bit more modular and supporting things like risk vectors instead of hard-coded CIA values. So for us, CIA may be a sensible thing, but we could represent that as a vector. If you wanted to use the OWASP risk rating methodology, you could use that vector instead. So there's some other cool stuff we can do there. A lot of the objects within the open threat model support tags, so it's a nice way of grouping or classifying things. There are X and Y positions for diagrammatic representations. If you've got a Visio diagram and you want to turn that into a threat model, you probably want your threat model in some other system to look similar to the Visio diagram in terms of how it was laid out. So being able to capture and transfer those X and Y positions is probably quite an important thing to do. You've got arbitrary nesting of trust zones and components, because that's, life is fractal, and so should threat models. They should be fractal as well. And we try to keep the number of required fields to a minimum. So there's a lot of the stuff you'll see here is not required and just adds additional context. In the process of creating this, we looked at what existing things are out there, what other tools are doing, how threat models are represented in various other formats. And so, we are sort of aware that from our point of view, from Iris Risk's point of view, we are at risk of introducing a 15th USB standard, or whatever this example was about. But hopefully it's got the best of most of the different sort of approaches out there to make it sort of really sort of powerful and reusable, but without losing some of the simplicity. I won't go to too much detail on this slide, but this just gives you a snapshot of some of the tools that we looked at. Not all of them. There are others as well that didn't fit on the slide. And we looked at what are the key properties were, and how does that relate to OTM, and what do we need to include in OTM to be able to work with, support, and expand on other tools, both in the threat modeling space, but also outside of threat modeling. So what's inside of the OTM specification then? Probably the most obvious starting point is the project itself. So this is the thing that is being threat modeled. Could be a code repository, could be a whole application, could be a combination of things. You've got some basic fields like a unique identifier. In the examples that I'll show in a bit, we tend to generate UUIDs, but they don't have to be, they just have to be unique. You've got some other optional values like the owner and the owner contact, which is useful. And we have some examples here of some attributes. So maybe you want to be able to record where your application's documented, or maybe you've got a configuration management database and you want to capture the ID for this application or component or whatever it is inside that CMDB. So you can capture any of that sort of stuff arbitrarily. So that's that project. There's one project for an OTM file. We then have a representation section, and you can have as many representations as you like in a single OTM file. In this case, we've got an architecture diagram, so it's a bit of a description, and its type is diagram, which means that we expect to see size attributes that are, no, I shouldn't, size fields. So we've got a width and a height associated with this diagram so that we can faithfully recreate it when passing the OTM file in some format. And as you said, from a component point of view, we can then track X and Y coordinates. Here's an example of a code representation. So the type is code this time. Again, we've got a name and a unique ID, but in this case, we've got a repository. So where's the URL to this particular piece of code? And then we've got some optional attributes that we can, add in, such as the language or the platform or what VCS it's using. Assets are, as I said before, the kind of things that you care about. So in this case, we're looking at credit card data. So basic description of what that asset is. This is one of the pieces that the specification's a little bit opinionated on, and maybe we need to revise this, but an asset should have associated with it some sort of risk variables. So how important is this asset to us as an organization? In this case, we were expressing the risk in terms of the confidentiality, the integrity, and availability. It would be really bad if somebody stole this information and it got out there. Would be very bad if somebody could tamper with it and destroy the integrity, or it would be very bad if this asset was unavailable to our customers. So, we're using the CIA triad in this case to describe that, but we might have to revisit this, maybe, as I said before, along the lines of vectors or something a bit more generic. The nice thing is you can provide a comment as well about why this particular, these particular values were selected. So that's provided as a field as well. Trust zones then, the one, it'd be interesting to hear people's opinion on this. Trust zones are nice because they're very clear in terms of the boundaries between what's in a trust zone and what isn't, but more other approaches, boundaries, and the boundaries tend to be relative to two different components. So it's not this component is in this particular trust zone, which means that it has certain properties from a security perspective or from a trust perspective. Trust boundaries are more relative between two different components. So at the moment, the specification refers to trust zones. So a component can be in a trust zone, and that has implication in terms of what's the risk rating associated with that trust zone, and what representations is this coming from? Are we looking at this trust zone in terms of what it was in an architecture diagram, or are we looking at it in terms of what repository it was in terms of code? So maybe your infrastructure, your public cloud code repositories are associated with trust zones that are of a higher rating than something that was publicly facing, for example. Components, these are the building blocks of any threat model. Some people might call them elements, but I think component is a pretty standard term here as well. You've got your name, you've got an ID. The type is a key field here because that lets you specify what kind of a component it is without necessarily having this full-blown taxonomy. We just want to say this component is an instance of something, and when you know that it is an instance of something, you can make decisions based on that, and maybe you do have a whole taxonomy of those somethings, and what we're just doing is creating that relationship between, in this threat model, this is a certain thing. Of course, we need a parent, so this component doesn't just float in the air. It has some sort of context. That can either be a trust zone or it could be another component, so we can do that nesting. And then we can also see an example here of using tags. So tags are arbitrary. You can have whatever tags you want to group or to classify or whatever you, those components. Is another example of a component. This previous one was sort of fairly basic. This one is now referring to the representation. So this component has a representation from a diagram point of view. So we can also provide the X and Y and width and height associated with this particular component. Whereas this one is looking at it from an asset point of view. So this component processes or stores these assets. Again, it doesn't have to be UUIDs, but what these are unique identifiers to other assets that were defined previously, and your components either processing or storing them, as I said. I'll come back to that. Yeah, okay, interesting. I think the world might be a bit divided on trust zones versus boundaries. Data flows, components. You can actually get quite a useful threat model just by dropping components into the threat model and not really caring about the data flows. But I think you take a threat model to a whole nother level where you're able to look at the context of the threat model in relationship to those data flows. So the data flows are fairly fundamental here. As you'd expect, name, ID, description. We've got a direction. Is it bidirectional? Is it one way? And of course, we have a source and a target. So in this case, the source is always going to be a component. So it's just the component ID here, as is the target. And then we've got, again, tags. So it's kind of, we're just building up a graph at this point, basically. Threats. So at the moment, what we've been talking about has primarily been the sort of the really about the representation of the system itself, the trust zones, the components, and the data flows. But the OTM specification also includes being able to relate and describe the threats themselves. So you've got a section in the specification to provide all of the threats, name, some sort of identifier, description. The categories is arbitrary, but in this case, we're using stride. So you can relate this threat to spoofing and tampering, or you could relate it to technical threats or business threats, for example. There is a CWE field that allows you to then relate it to CWEs, of course. It also includes a risk section as well. As I said before, maybe subject or maybe better replaced by some sort of vector. But in this case, we're talking about what's the likelihood of this threat and what's the impact of this threat, plus a comment. And here's a mitigation, very much what you'd expect: name, identifier, description. Risk reduction is a value that says, well, how much impact does this mitigation have on a threat associated with it? And then we've got some attributes such as, what standard does this relate to, or where, is this mitigation itself a component or something in my CMDB? What you can do is then associate threats and therefore the countermeasures with the data flows and components. So I may have a data flow between, in this case, a web service and Mongo database, and this is a threat that is a result of that relationship between those two services. The state of that threat is exposed because we haven't mitigated it in this case, and that mitigation is required. So and we're applying this in this context to a data flow. So it's at this point within the data flows that we're gluing the threats and the mitigations into the context of that particular data flow, and the same thing for the components as well. So I didn't show this originally when I was talking about the components because we were just focusing on the components themselves. But when you look at that structure of the components, you'll also have the threats and the mitigations associated there if you wanted to put those into the OTM file itself, and they then refer to the threats described previously, or in a different section. So I'm doing okay for time. What does this look like in practice? I'll give you a quick demo of taking a dot file, which looks like this. So we've got internet, we've got some sort of a photo client. It talks to an upload service, which writes to an image database and an analytics API. So this is a dot file that, we've got a blog post that says how to create a basic OTM parser, and with 100 lines of Python code, we can parse a dot file following a certain convention and generate an OTM file from it. So that's what I will just show now. So this is the dot file. We are making a number of assumptions here. So a subgraph is the trust zone. A node in that trust zone is a component, and we're getting the name from the label and the type that I referred to earlier from a new line within the parentheses from that label. And then we've got a data flow either inside the clusters or outside of the clusters, between the clusters. And here's about 100 lines of terrible Python code that I wrote that will pass through. What it does is it iterates through the trust zones by looking through the subgraphs. For each of those trust zones, it iterates through the components. Each component must be in a trust zone, just sort of by convention to make things easy. So we iterate through those nodes. We iterate through the edges within the trust zone, and then at the end we iterate through the edges outside of the trust zone, outside of the subgraphs, and we then spit it all out into an OTM file. So if I can find the right, because I'm lazy, everything is hard-coded in this file. So we literally just write a hard-coded OTM file as a result, using JSON. So if I run this, don't even print anything. I'm that lazy. Wrong one. We should now have an OTM file, in this case a JSON file. So we've got a representation, which is a dot file, which we're saying is a type of code. Yeah, maybe it's diagram. We've got some trust zones that were hard coded, and then we've got our components that we were able to extract from that dot representation, as well as the data flows. It'd be relatively trivial to write something that generated a dot file from OTM, of course. So you could go and create, using GraphViz, go and create a visual representation of OTM using GraphViz or dot files. In Iris Risk, this is what it would look like, and as you'd expect, it's a threat model, so you'd expect to see threats and countermeasures, etc. If you wanted to get started creating an OTM parser, we have that link shown there that just talks through how you may go about it. There isn't one correct way to create a parser for OTM. It's just a data structure. You create it however you like, but it's just providing a bit of an example. The other more interesting use case here is being able to take CloudFormation and generate an architecture representation of that CloudFormation. So typically when you look at a visual representation of CloudFormation template, it's normally just some sort of spidery mess of all of the resources in a CloudFormation template and how they all sort of relate to each other in terms of the hierarchy. That's not really what you'd expect to see from a threat model point of view, which is really going to be looking more at an architectural perspective. So what we've got here is a CloudFormation template that's very much centered around ECS. So, and it's got some security groups and all that kind of stuff. So it's a fairly typical CloudFormation template. There is a project on our public GitHub called Start Left. And what that includes is the ability to pass CloudFormation and generate an OTM file. In this case, I'm going to run this, and it's also going to send it to Iris Risk, but we'll ignore that for now. So if I run this, what it's going to do is it's going to run a map against the CloudFormation, and that mapping file here basically says, here's how to go and find stuff in a CloudFormation template and what to represent it in terms of a threat model. So let me just quickly have a look at that file. That's the wrong one. So this mapping file, it uses JMES paths to go and query the data structure associated with the CloudFormation template and say, right, here's how to go and find a CloudWatch component. Here's how to go and find a DynamoDB component. Here's how to go and create a bunch of data flows. And the data flows in this case are based off of the security groups. So what we end up with is, that's the CloudFormation template. What you end up with is, as you'd expect, a OTM file that has a representation. It has some trust zones for public cloud and internet. And it has all of the components for the VPC, the subnets, the ECS cluster, and all that kind of stuff. But it also has data flows based on those security groups. So because we saw a security group connection from some sort of a component or subnet over here to some sort of a subnet or internet address or something over there, we know that we're expecting some data flow to flow between them. Otherwise, there wouldn't be a security group. And so we can create that data flow off the back of the security group. Something we're going to work on in the short term and put it into the project as well would be creating data flows based on IAM. So if an EC2 instance has the permissions to talk to an S3 bucket, we have to assume that there's some sort of a data flow there as well. So that's something that we'll be working on in the not too distant future. And this is what you get as a representation. So you're seeing components where they should be. We've got nested structures you'd expect. The task definition sits inside the ECS service, which then sits inside of the subnets. And we have the data flows to the various services, either within the subnets or to the internet potentially as well. I'll come back to the questions in a bit. So next steps. So it was literally only 2 or 3 weeks ago that we released OTM. It's linked here, the open threat model on Iris Risk's public GitHub. As I said before, Creative Commons. Very much looking for feedback, very much looking for suggestions on the specification itself. If you're interested in like writing a parser or implementing OTM somewhere, please let us know as well. We'll continue to write parsers and things like that for it as well, but a lot of our customers are also looking to implement parsers for it, but it'd be great to be able to work with a broader open source community as well. And there's a broader, well, a sort of slightly longer introduction to the open threat model standard from an Iris Risk perspective. If you want to get in touch, feel free to drop an email to otm@irisrisk.com. And with that, I think I will try and go through the questions. Presumably somebody should be recording. Yes. I really like that you're using trust zones rather than boundaries. This is great. I'm actually developing something similar with JSON files. Oh, okay. That's awesome. Yeah, please do chip in, as the OTM file is essentially JSON or YAML, so all good there. I wonder how big of a team do you need to implement it? Is it feasible for small teams? What do you mean with implement it? Oh, you have to drop. Oh, that's right. I'll catch up with Petra later. You know, you have to instantly say whether you cover Terraform now. Ah, right. So Terraform is an interesting one. For AWS, we kind of almost cover that for free, because the way the parsing works is it goes and reads the CloudFormation file, which is either JSON or YAML, into a data structure. Now there's a Python library called HCL2 that reads the Terraform HCL files into a slightly different data structure. So all you have to do is say, okay, instead of here's how to find this component in CloudFormation, here's how to find the same component in a slightly different way in Terraform, assuming AWS. Obviously, things get a little bit different in terms of Azure or other things within Terraform, but in fact, from our point of view, our next sprint, we're actually going to be finishing off the current implementation of the Terraform parser as well. Flow logs would be interesting, because you're really talking about live data. So in principle, right, I guess you could write something that goes and queries a live AWS account, looks at flow logs, and generates a bunch of data flows if you can sort of infer the components. So yeah, you could in principle go and query a bunch of live running data and generate an OTM file from that for sure. Are you familiar with OWASP pytm? Yes, absolutely. How does it compare to it? So if I just quickly scroll back, right, so we did include pytm here. I don't know if Izar's on the call. How do you prefer to call it? pytm or pytm? pytm is awesome because it's executable Python, which gives it gives a lot of power. But you have to then actually implement it in Python. OTM is agnostic to the language, so it comes at some of the cost of the flexibility in exchange for simplicity and transferability or agnostic language agnosticism, if that's such a thing. So I think Izar was actually interested in looking at OTM as possibly supporting it alongside, or maybe have pytm output OTM as an option. I've got an open source project called ThreatSpec. I'm probably going to rewrite that in the not too distant future to just basically pass source code files, extract the threat model context from the source code file, and just spit out an OTM file as instead of the crazy mess that I'm doing at the moment in there. So good question. The examples are software focused. Have you considered physical hardware security? That's a good question. Fundamentally, you can just create an OTM file in an IDE. You can just handcraft. It's just a very simple YAML structure. It takes nothing to just go and write some YAML that represents a threat model in OTM. So you could do that. If you've got some sort of asset database of your physical and hardware security, if you can read that data, you could definitely generate an OTM file for those hardware assets. I wouldn't want to be the person having to sort of walk around a physical room trying to count the number of devices, but if you've got that somehow represented in a database some way, you could definitely leverage OTM just to sort of to put those hardware or software assets, the hardware or physical assets, into the context of a threat model for sure. Open threat model repo doesn't have the schema. It should do. Does it? No, it does. It's right. So yeah, there's yeah. I think I know where the confusion is coming from. In this repository here, the README describes the schema as in terms of a document. We've had a couple of people ask. There is in the start left, in order to make the start left project work properly, there is a JSON schema file that we use to validate the OTM. That definitely does need to be moved out of, or at least copied out of, the start left project and put in here as an example, and should be as a source of authority in this repository. But the Creative Commons specification itself is this README. This is where this will be the source of truth for what's in the specification itself, and then we will, as Steve Spring says, we'll need to move the JSON schema file for validation into this repository. I will make sure that we have a task to do that. pytm, but hello Isa. We will be supporting OTM output. Oh, cool, very good to hear. Any other questions? I don't know if people can unmute themselves, but feel free to if you can.
If you'd like to unmute yourselves to ask a question, just feel free to put it in the chat, and I'll see if I can unmute you. Okay.
Where would a user of this be expected to get the CIA scores from? Yeah, that's a very good question. So it's how facetious do I get here? All right, I'm gonna. This is Open Security Summit, so I'm gonna allow myself to be myself. Where you would get any other risk management value from? Thin air, right? So if you were doing you have to rely on certain judgment, certain expertise. So if you're talking about an asset, and the CIA ratings for that asset, I would go and speak to the product owner or the business analyst or somebody who knows how important is this asset to that organization and say, you know, is this important? How bad would it be if we lost this data? How bad would it be if someone changed this data? And then we tried to stick to something fairly generic. So the values are just normalized from sort of 0 to 100. So you can interpret 0 to 100 however you like. If you want to treat, 75 and above as critical, then you can do so. So it's the same as you'd come out with any other risk management value, such as the OWASP risk rating method. You have to go and talk to the right person who knows what they're talking about to get the context for that. I'm on headphones. Thanks for reading it out. No worries. Have you reached out to other TM tool project vendors? If so, what does the future adoption look like? Great question. Focus mostly on getting feedback at this stage, as we've seen before. From an open source point of view, that's probably where this project's going to be most impactful in the short term. We've not reached out or spoken to any commercial vendors at this stage. Not in the threat modeling space, actually. We have spoken to some other security vendors who are very interested in what we're doing with OTM. So, if you want to be able to interpret your SAST scores in the context of the threat model, then OTM can sort of help that, for example. But we're really just about getting this out into the wild and getting feedback and iterating on the specification and seeing how the community responds. CVSS score, yeah, that comes back down to this idea of maybe we need to rip out that CIA stuff or any of the other risk stuff and replace it with a more generalized vector. So if you want to use CVSS, or if you want to use the open OWASP risk rating methodology or anything else, if you could represent that as a vector and you could say it's this type of vector, then you could support CVSS, for example, as well. With 3 minutes to spare, any further questions? I'll close that. Again, feel free to reach out to the email address. I have access to that. I'll see it come in. If you have any further questions, or hit me up on Twitter. Let me just put it in the chat. That's me on Twitter, so feel free to reach out to me there as well. Otherwise, thank you all, and thank you to the organizers of the, once again, awesome Open Security Summit.
Thank you.
Thanks, Fraser. That's brilliant. Thanks, everyone, for coming. Bye.
Thanks, everyone. Thanks for the questions. Bye.